Welcome to SkyRadar drones, the close-range radar to discover small intruders. Drones are a wonderful invention for police and fire brigade, for homeland security and entertainment. Virtually any segment can benefit from the technology, but mind if it gets into wrong hands. In order to control, to detect, to find drones, we have to think about their features. Drones are small, they're silent, they're mostly made of plastics. They're fast and they can hide behind obstacles. To detect them we need fast sampling rates to track all the movements, like in weather radars. We need moving target indication to discriminate potential targets against clutter, like trees or birds. We need moving target detection. We need the possibility to color targets to differentiate between targets and non-targets. We need to be able to screen through obstacles, even concrete walls, to detect our targets behind. We need precise cross-section analysis and comparison to model the correct shapes out of our data afterwards. SkyRadar drones does all that. Our FMCW radar system has a very high performance. It works with 16-bit data processing and it has a sampling rate of 250K per second. This produces highly resolved log files. These log files are the basis for the following analyses. There's a whole range of clutters that need our consideration. There is volume clutter, like weather or chaff. There is ground or sea returns, which we call surface clutter. There is point clutter, birds, windmills or individual tall buildings. Especially difficult to detect and to blind out are those which are called moving point clutter, sometimes also called angels. Birds and insects produce such a clutter, which is pretty difficult to remove, because the characteristics are very much alike aircrafts. What does SkyRadar do? Since aircraft usually move much faster than weather or surface targets, the velocity-sensitive SkyRadar eliminates unwanted clutter from the radar indicator. Such a system is called moving target indicator. But SkyRadar does much more. Surface clutter is eliminated through electronic maps and statistical methods. Point clutter is eliminated through statistical methods. Having produced our log files, we can then start doing the analysis. Once that is done, we can color or blind out our targets. Everything that is considered clutter can be blinded out. We can color our targets in a way that we indicate what is considered important but not malicious. And on the other hand, we can highlight what potentially is dangerous. So we get a better overview on our radar screen, which is cleaned of everything that might be disturbing. Radar can screen through obstacles too. This is another advantage in comparison to cameras. Look at this concrete wall here. The flags behind have been properly screened and the now visible cross section has been produced by our system. Precise cross-section analysis, that's the key word and prerequisite for a proper drone detection. We work with several methods. We make use of inverse synthetic aperture radar, the ISER, to produce high-resolving picture. We make use of the electronic data measuring EDM. We use the frequency shift keying operation mode for high resolution of moving targets. Having produced high resolution images, we are able to compare our live data with data that comes from our database, either from our database or from any other electronic warfare database where data is communicated to us through the Asterix communication interface. SkyRadar comes as operational system for military and homeland security applications, for the protection of airports, of borders, or of any perimeter of national importance. It comes as a training system for military and civil users, for operational users, and for universities. And it comes as an experiment and research workbench to gain experience and data on drones and their detectability. And if you want more, we certainly find a solution.